Thank
too.
you.
Bye.
Bye-bye.
Have a nice day.
Bye-bye. Okay, so that was a great interview from our Pro Vice Chancellor of the university. So now let's go back into the space topic. So as you may know, space applications revolutionized our society, and it's used on daily basis, pretty much every day. Just think about GPS, localization, synchronization of the time, navigation, internet, communication. Everyone uses it all the time, even without knowing it, but we use space application every day. And this has been possible thanks to our capacity to launch satellites into orbit since quite a long time, 1954. The Sputnik 1 satellites, which is, remember, on our logo right here, on Quantset's logo. Yeah, we have this capability for a long time.
Yes, because launching is a thing, but as you know, we are launching more and more satellites in these times, and space debris has become a real issue, as of our previous speakers have already explained to you. So this cohabitation of the orbit between debris and new launches is quite dangerous, mainly because a collision can actually entail the multiplication of this space debris.
Yes, exactly. This is especially called the Kessler effect. And to avoid to get to this point, we invited three guest speakers, specialists on this domain. So here they will appear on your TV. Yeah, hello everyone. So I will introduce them one by one. So starting with Tanveer Ahmed, who is joining us from India. He is the co-founder and chief technology officer at Digantara. So he has a keen interest in spacecraft safety, interdisciplinary research, and he decided to create its own startup a few years ago, quite recently, yeah. And so he's developing a constellation of patented CubeSats for tracking resident space objects in orbit.
Yes, so I'm going to go to the next speaker already then. This is Daria Serfontaine. She's actually a PhD student here at Cranfield University. She's doing her she's doing her thesis in space debris mitigation, and she's actually very involved in this subject. She is also Leonidas Fly Your Thesis team leader. She's doing the Fly Your Thesis program at ESA, and she's looking forward to experience microgravity by the end of this year. So I just want to say thank you, Tharia, also for joining us today. So the next speaker.
Yeah. And so the next and third speaker of this panel is Bruno Carvalho. Thank you, Bruno, for coming here. He is joining us from Portugal, where he is the president of this new space company, Deorbit Portugal, and providing solutions covering the entire life cycle of a space mission, including mission analysis, design, engineering, manufacturing, integration, testing, launch, and most importantly, I think for today's topic, the end of life decommissioning. So thank you for all of us for joining us. There are three specialists on three different aspects of the space sustainability. And I will address my first question to Tanveer. So could you explain a bit more about the current situation of our low Earth orbit? And how are you planning to monitor it with your company, Digantara? The floor is yours. Yeah, you can go on.
Yeah. So currently there are around 1 million objects that can potentially destroy satellites, and of them.
Oh, your sound is going a bit off.
Yeah.
Okay.
Could you repeat this? Yeah, it's fine.
Yeah. Can you hear me now?
Yes.
Yes, now we can perfect.
You can go.
Okay. So there are around 1 million objects in space that has potential to destroy satellites, and among them, less than 4% of the objects are.
Oh, you are getting off again. Make sure your microphone is like open, like everything is good with, yeah. But now you're back again, so I think you can go.
Okay, I think I'll try another time. So among those 1 million objects, just 4% are being tracked right now with ground-based systems. So that's where we are trying to build a space-based sensing for space that don't have any.
Oh.
Okay, so there might be a little bit of problem with his sound, so don't worry, we will try to fix it in the meantime. If you're okay, can you hear us down here? We're going to go to the next question, which is going to be for Zaria from Cranfield University, if you don't mind, and we'll try to get back to you as soon as possible. So Zaria, my question is actually, why do satellites stay so long in orbit, but also, why is it a problem, and how does your research, your thesis research, actually apply to this? How is it trying to solve this problem?
Yeah, so big questions. I think to start off with, why do satellites stay so long in orbit? We designed them. I think we want them to stay long there. We want to get as much information from them as possible, and depending on what altitude they're at, the atmosphere just gets thinner and thinner. And normally, the way that something naturally deorbits is through atmospheric drag. So over time, they eventually just get closer and closer to the Earth and then burn up in the Earth's atmosphere. But the higher we put them, the longer it takes to do that. So it was quite shocking to learn just how long it can take for a satellite to deorbit, especially when you get kind of over about 800 kilometers altitude. It can take decades or even hundreds of years. But I think usually for those ones we include active deorbit options. So why is it an issue? Where we have a lot of momentum in the space industry at the moment, which is amazing. We have new players, we have industry, everybody's coming together, and we're just adding to the technology and the research that we're doing, and we're doing more and more. But that also means that we're kind of cluttering the space area. And for the moment, it's still fine. There's still a lot of space in space. But at the rate that we're going to be launching more satellites in a year than we currently have in orbit in total, and that's going to be soon. And policy is difficult because space is a shared space. It's shared by all the countries. So if we wait for policy to catch up to tell us what to do about the orbit options, it's going to be a little bit too late. Yeah, sure. But we can see that industry players are actually pushing for having a more sustainable space and having a cleaner space, because it benefits everybody. Nobody wants to be in a situation where your satellite dies. Yeah. Nobody wants to be attacked. So from our side, what we do at Cranfield University is just drag augmentation systems, so drag sails. And basically, we're just targeting those satellites that are really small, that don't have their own propulsion systems, that are cheap satellites that don't want to have to think about an expensive or a heavy option that's going to affect their mission very heavily. So we just want there to be an affordable, low-impact solution.
Okay, great. Thank you for your answer. You're absolutely right about everything you said. We need to protect our low Earth orbit, and I think everyone agree on that. From everyone on Earth, everyone needs space today, and so. Before getting back to Tanvi, we will follow our momentum, and I will ask you a question to you, Bruno. So, could you, Bruno, explain us about what is orbit servicing, and how is it going to be a real game changer in the space sector? Over to you.
Good morning, and thank you for the invitation. It's a pleasure to be in this event. Well done to all of you. There's two parts of that question, because in-orbit servicing needs to be planned on the ground. And I think, as Zari was mentioning, all players that are currently involved in the space industry, I think they are realizing that they need to plan ahead before actually launching anything. And I'm in a company that develops in-orbit logistics. The thing is that I would prefer that you don't launch before being sure that you can launch safely and operate it safely and actually making a difference with what you are launching into space. If you can do it cheaper on the ground, if you can do it cheaper on Earth, with whatever type of sensors or balloons or communication towers, just do it, because you're going to save a lot of other problems for yourself in terms of also the investment that is required, but also prove the concept before actually launching. And I think that's something that has to do with in-orbit servicing, in a sense that we planned, as I was mentioning, for long-term duration missions. Satellites would want to stay there for as long as possible. And there are several types of in-orbit servicing. One is mission extension, so just allow them to stay there for longer. But for that, you need to send other stuff into space, so it's kind of reinforces the cycle and the feedback loop. The other option that is currently being addressed, and the UK is very actively on that, is the space debris catching up. So basically clean up the orbits, but it's also tricky because if you mess up, you just break stuff in pieces and you create a bigger problem. So again, planning ahead. So to be honest, I'm not a big fan of in-orbit servicing. I mean, it will happen, but they need to be carefully planned. And for me, in-orbit servicing is more about when you start building in orbit, when you start building bigger structures, when you're starting operating stuff that you can't just launch from Earth because they're too big or they're too cumbersome or too fragile to be launched the conventional way. So that's when the fun starts, and then we're reaching into what I'd say sci-fi realm, but at the same time, it's where things become interesting. But that's what the orbit wants to do. It's about the logistics problem, not so much the servicing problem, which is more important.
Okay, I think I'm understanding. So before going over to Tanvir, I'm going to ask you all a question, because Zarya has already talked how these satellites are supposed to naturally, with the drag, deorbit. But actually, we have been talking about this mitigation for long. But can we talk also about avoidance? Can we talk about how, if all of these satellites have a realistic deorbiting plan, is it enough? Can we prevent this problem beforehand? All of you can take the question, by the way, and you can complete each other's answers. Sorry for that. Over to you.
Okay, I'll start. My mic is open. Yes, we need to do it. Otherwise, we will struggle. I mean, we need to plan. We need to plan for debris mitigation, and that starts, as I said, on the ground. So it starts from the mission design. The mission design is very important, not just to plan for the actual, as someone was saying, but also during the operations. And the operations is, about collision avoidance. How are you going to do it if something comes your way? How are you not going to get into the way of something else? What orbits you're going to use? I mean, changing the angle inclination by half a degree is probably enough to avoid a lot of issues. And our orbits are very, very crowded at the moment, and becoming even more crowded because they are the cool, interesting orbits, right? So, I mean, if you have certain applications like Earth observation, you want polar orbits and high inclination orbits. So there are some specific things that you can do to try to avoid the issue. But it's engineering, so it's never 100% fail-safe.
Yeah, I think part of that. Oh, sorry.
No,
I think
go
part
ahead.
of that is what Tanvir is doing at the moment. So it's creating a better idea of what we have in orbit at the moment, because that's a big issue we have. We can track things bigger than 10 centimeters in diameter, but things that are smaller can still damage our spacecraft. We saw that happened to the ISS arm just a few weeks ago, where it was damaged by something we couldn't track. So the whole area of space traffic management, like what Bruno was saying, the logistics of it, organizing it, making sure that we know where everything is going to be is really important. And for myself as well, I'm slightly concerned about the CubeSat class. It's a very exciting new class of satellite. Nanosatellites have been growing in popularity a lot, but most of the CubeSats that we sent up don't have maneuverability. So even if we were able to predict they were going to collide, we can't do anything about it. So I think as we go forward, that's going to be a big area as well to talk about, especially since they're at lower orbits, which larger spacecraft have to pass through to the orbit.
Yes, good point. And speaking about CubeSat, maybe if Tanvir, you're back with us with the connection, you can explain us about how your CubeSat constellation is going to monitor these objects so that we can avoid in advance. Like we can predict when there is a risk of collision, and yeah, I think you're the best place to speak about this surveillance system.
Yeah. So one thing would be increasing the resolution, like to like less than 10 centimeter. That's what we're trying to do.
So, actually, I'm so sorry, but apparently we cannot hear you when you're on the full screen. Can you try when you're on the small TV? Can you try again, please? Sorry.
Yeah. So can you hear me now?
We really cannot hear you.
We can hear you very low. So
Yes.
maybe try to go a bit closer from your microphone. It can help.
Sorry for
Can you hear
this.
me now?
Oh, it's
Yes,
better.
that's way better. Yes. Do you
Okay.
need us to remind you the
So-
question?
No, I
Okay.
was able to hear you. Yeah.
Great.
So suppose we were able to identify a collision well beforehand, a few weeks ahead. That's what we are trying to do. So.
Okay, so apparently we're being told that there might be a problem with the sound. It's not the internet connection. Okay, so please, Tanvir, if you could actually try to leave the session and join back. In the meantime, we'll go to the rest of guest speakers. Once again, sorry for these technical issues. It's just things of life, I guess. So let's go to Zaria, if you're ready, please. Can you please explain us how to mitigate the risk of losing a satellite after an impact? And also, you said a very interesting theme just before, how CubeSats don't have maneuverability. Can you also explain a little bit on that? Maybe there's some people in the audience that don't really understand the difference.
Yeah, so avoiding collisions, that's a big topic. I think mainly it's all about planning. So something that we haven't really had to think about before was what altitude we're launching to. So before now, it's always been a technical issue. So it's been, what altitude do I want to go to get the most from my experiment scientifically? But now with space debris regulations and things like that, there are certain orbits that are more preferable because you can deorbit quicker. There are certain altitudes that are more preferable because they're easier to get to. When you're launching, especially as a small satellite, you kind of have to go to whatever orbit someone else is going to, unless you use one of Bruno's vehicles that can get you to a different orbit. So that's always there. But I think it's all about planning, and it's all just about, as I said before, just increasing our knowledge of what's currently up there. That's going to be key. I have forgotten the second half of the question.
Don't worry, I will remember it for you. So the first one was actually, can you explain us how to mitigate the risk of losing satellites after an impact?
Yeah, so that is interesting. I know ESA Max at the moment, they designed the ESA debris tool that you can use, and they designed it to try and test what happens when debris hits your satellite. Because it's going at 7.8 kilometers a second, it doesn't behave mechanically the way that we're used to it behaving on Earth. So hypervelocity impacts are very different to normal impacts. So I think, just gathering more information, testing, making sure that if something impacts your satellite, it doesn't do significant damage. There's ways of protecting that, but most of those ways are very heavy. So it's always going to be a trade-off between, adding more mass and adding more protection versus having a safer satellite. But I think we can start by cleaning up the space debris environment. We'll have less risk of collisions. That would be great.
That's a good point, yeah. Like we can shield the satellite, but maybe if we can avoid to have this shielding, because lifting mass into orbit is always, someone need to pay for it, so if we can avoid it, it's better. Okay, so I heard that Tanvi is maybe back to us. So let's try to avoid the satellites by knowing where they are, and let's go, Tanvi. Floor is yours.
Okay, let me just check if you guys can hear me.
Yes, we
It's
can.
definitely better.
Okay, what was the question? Can you just repeat?
So the question is how your system is going to monitor the space, the objects, to detect them, so that we can know beforehand with the more precisely the risk of collision.
Mm-hmm.
Yeah. So firstly, by detecting more number of objects, having a larger catalog, then using these observations like space surveillance observation and doing something, determining their object or determining their orbits, and then advancing their orbits in time for a period of 2 weeks, so that we can identify a collision and report a collision well within 1 or 2 weeks, so that the involved stakeholders, the two objects, can take certain measure to avoid such collision. So that's what we are trying.
That's great. Thank you very much, Tanvir, for this answer.
And sorry for the technical issues.
And we are sorry for the technical issue. Even if we did the tests beforehand, sometimes things happen. So we hope that space application will improve the connection worldwide. I think it happens, like it's problem of life stuff. Yeah.
So let's continue with the questions.
Let's continue. So I will go back to you, Bruno. So the orbit provides a lot of different service, and like what can the orbit provide for service, Bruno, for minimizing the risk to getting collision? I think you have like software and attitude control systems and orbit control system. So yeah, could you go on?
We act on three vectors mainly. One, as I explained before, we would help you test your technology and deploy your technology before you actually have to have your own mission. That avoids the issue that Sari was just mentioning, that you have a satellite that's uncontrolled in space because you don't have propulsion or you don't have mechanisms to avoid that. I do expect that regulations will catch up, and like you now have a plane with ADS-B on board, that you'll have something that will be imposed on satellites to be tracked. Which comes back to what Tanvir was saying, we need more information. And this is one of the vectors that the orbit is addressing as well. So we are actually capturing information in orbit related to debris. So basically we're flying a camera at the corner of each of our satellites. Basically we call it DSense. It's used for star tracking, but also for Earth sensing and for sun sensors. So basically pointing and guiding. And because we also have a GPS receiver, basically what's in the camera that is not the Earth, the sun, the moon, the stars on the planets, it's debris. So we can trace that and correlate that information with our GPS location and basically our tracking. So we're feeding into the catalogs that are not just available worldwide, but also need to be complemented. And any information that is on those catalogs is useful, and we need more of those. So that's not too much. So knowing where stuff is very, very important. And the third aspect, as you're saying, is about trying to avoid the collision. So we do have actually we work with students here in Lisbon, but also in the UK, to develop some tools for conjunction analysis, because the catalogs are so big that you need to start filtering and assessing what's the risk of those objects to actually collide with us and collide with our customers, because as Zari was mentioning, we do deploy other satellites, so we place them in their correct slots, and that means that we need to understand what's around us, and by that we need to take into account all those catalogs and huge amounts of data, try to propagate those orbits and correlate those orbits and see what is the probability of conjunction. And by conjunction, I mean what's the probability of actually having an impact. So you, at the end, have a number, probability plus the covariance of that, and you make an informed decision about the risk you were willing to take before having a maneuver. So it's all you can do at the moment. I think things are becoming more automated. That's the aim. But it's really impossible to automate before you actually have international guidelines about how to do it. And to give you an example, I mean, SpaceX Starlink they claim that they have automated maneuverability, but they never used it, and they already had to perform avoidance maneuvers with OneWeb, with AOLOS of ESA and others. And the reason why they can't use the automated maneuverability is because you don't have the rules defined. On the road, you have the cars running on your left in the UK, right elsewhere in Europe, and you know that you need to stay on your lane. So you're facing head-to-head, you swerve right or you swerve left, depending on what country you are. But if you're in space, are you going up, down, left, right? And actually, you can only go up and down, and actually need to plan that maneuver ahead of time. So it's not something that you can do in real time. So you need to fire your thrusters long way before planning for the propagation of that orbit. So that adds another level of complexity, which is enormous.
Yeah.
But maybe I'm deviating a bit of the question, but those are the actions that are still for us research topics. Yeah,
sure. I think that's a very good point, because there are a lot of objects around us, and we don't really know where they are. And this risk analysis, as you said, we have the probability with the uncertainties that can be with the orbit propagation. We cannot know in advance when it might happen, a collision. And so going back to our panelists, so on this risk analysis, we have, of course, the risk in terms of probability and the risk in terms of gravity, how dangerous it is to get the collision. And maybe I will give this question to Tanvir. So in your opinion, Tanvir, what is the most dangerous size or kind of space debris? Is it are the largest one the most dangerous, or it's more the smaller one that are more dangerous, in your opinion?
Yeah, so there are three kind of debris that we have. One is the small debris; those are less than 1 centimeter in size. The medium ones between 1 to 10 centimeter in size, and the large ones greater than 10 centimeter in size. So greater than 10 centimeter size, they have the highest energy. So, if you get hit by them, there is no chance of survival. That's pretty sure. So those are the most, but there is another kind of risk involved in current situational awareness. That is, for medium-sized debris, you cannot effectively shield them when a collision is about to occur. There is no strategy that you can put a strong plate onto a satellite or so that you can shield the satellite from collision, while there exists in small debris. And adding to that, there is the current space surveillance systems cannot detect these objects. Even if, first of all, you will not get to know if there is a collision, and even if there is a collision, there is no way to conclusively tell that was because of a debris. I think the recent ISS collision was one such example, and there were a few in the past also.
Yeah. In any case, as you said, there might be some more dangerous space debris, but all of them are still dangerous. And I would like to go back to Zaria, if it's possible, because she has mentioned a few times how important is to do this planning for this kind of programs in which you're trying to mitigate this effect or avoid it. And you have been all talking about planning in every method, in avoidance or in mitigation. Can you please explain how does this planning work? For example, in your case, since you're doing a PhD, I assume it's a very long-term process. Can you please elaborate on that?
Yeah, so I think this is where it also comes down to, like what Bruno was saying, regulation. So at the moment, there's, as far as I know, no conclusive worldwide method of how you can calculate how you're going to deorbit or when you're going to deorbit. And part of that is just because it's so difficult. Space is so complicated, perturbations are so complicated. We're trying to predict the solar cycle, but we're not very good at it, and that changes deorbit times drastically. So there's no kind of agreed upon system, because there is just no system that can capture every satellite's deorbit. So I think for as many different types of satellites we have and as many different types of missions we have to have as many deorbit plans. We have to have lots of different devices out there that people can choose from that suits their mission the best. We have to try and make them as easy to apply to their mission as possible, because if you think about it, like the satellite operators, although they want to be responsible, their main concern is their mission. And adding a deorbit option or implementing deorbit into your lifetime, that is going to be costly, and that is going to be adding some weight. That's just the nature of it. So the easier we can make it for people to do that, and the more we can talk about different options that are out there and work together to get a lot of different range of options out there, the better. But it's just very complicated. And another issue that we're having as well is, at the moment, there's this thing called passivation, where if your satellite is at the end of its mission, you want to try and dump all the fuel you have on board and discharge all of your batteries, because you don't want any extra energy on board if it does collide with anything, because that's just going to make everything worse. But that does mean that at the end of your life, you kind of have this option. You can either extend your mission if your satellite is still alive and well, or you can basically kill your satellite and implement your deorbit option. And I think even if I was in that situation, I would probably go towards extending the lifetime. But the longer your satellite is in space, the less reliable it becomes, and the less likely it is that your deorbit option is going to work. So there's just so many different factors that go into it that it's just, yeah, it would be amazing to have, if there's anybody looking for a PhD to do, it'd be amazing to have just a system that just categorizes every scenario that we can possibly have and tells you what is the best model to use for that to calculate your deorbit.
Yes, that's definitely a topic that is very interesting, and like we need more research on that. So maybe Cranfield University will propose some PhD. So if there are students here online, maybe think about it. And yeah, so you said about like the when we are planning a mission on the satellite, it needs to be like from end to end. So from the starting of the mission to the doing all the mission as long as we can, because like as we are launching something, we want to have to make the most of use of it. So but at the end, like we don't want to mess up with the other satellites, because in a long term, like the company want to have maybe other satellites, so you need to protect yourself in your future. So maybe to jump in for Bruno, like I know that deorbit is providing end-to-end services and end-to-end service, and like what do you like, at which stage of the project when you're working with your clients you're starting to think about this decommissioning of the satellites?
Yeah. From the start, we need to do it from the start, and that's also for our own benefit. We don't want. I mean, it's our revenue stream. If we can't go there because the orbit is entered with too much space debris, we lose our revenue stream. So we try not just to comply with the guidelines, but go beyond them, and we have to go beyond them. Otherwise, we would lose our own business. So if we are destroying customers, if we are taking them into orbit as a hosted payloads, whatever, we have to plan ahead. And I think that's part of because it's a little beyond what Sario is mentioning, because it's there's so many types of missions, and you can't possibly plan for all of them, because some of the missions are not even thought. You know, everything affected, from the material that the satellites are made to the shape of the satellites, or the attitude of the satellites. If it's more drag or less drag because of the surface area that is moving forwards. I mean, it is just so many factors that it's impossible to take into account. Now, what can be done is to try to again flag the issue and mitigate the debris by avoiding the issue, and that's kind of a vicious circle, because you need to go, but you need to avoid it. And so just it's a tricky situation, but we try to incorporate from the start, and we're working with our international partners. We're part of committees, investing our time and effort to try to define the rules of the game. Because if this doesn't happen, then we all lose. And I mean, fortunately, we're not the only ones pushing for this, and the UK in particular has been very, very active. And actually, the orbits in the UK as well, pushing for this and creating the partnerships. So it's a global issue, and I think the community is engaging. So it's quite good.
I think you just raised a very interesting point indeed. You just said, well, that the planning is very hard. I'm assuming there's a lot of factors, there's a lot of trade-offs to take into account. And also you just talked about countries. So I also want to go back to something that Zaria mentioned in her first intervention. She talked about the international policies. So I would like, actually, any can jump, maybe Tanvir or Zaria, since Bruno just finished answering the previous question. But can you a little bit explain how necessary is this coordination in between different countries? Because this is a shared space, after all. I couldn't say it better, I guess, because it's really in space. But anyways,
space,
yeah, it is. So just how important do you think that these kind of international policies are, and which are the latest news you know about these kind of things? So either Zaria or Tanvir, whoever you want.
Yeah, I'm happy to jump in. I'm very new to the policies, but I was very confused when I started learning about them, just because there is no other sector that works like this. Like you said, it's global. We have guidelines, but guidelines aren't necessarily law. They're not necessarily standards, but they are enforced by the launcher country. So normally you have kind of from the top level, you have your UN COPUS and your IADC. They kind of set the debris mitigation guidelines. And at the moment, that's things like the 25-year rule, which states that you have to remove your satellite from orbit in LEO within 25 years of end of life. And then it's kind of up to the different countries to then implement that themselves. So, you know, in the UK, if you want to launch something, you have to get a license. And to get a license, you have to show that you're complying with guidelines. But I think what Bruno was saying was very true, that like the guidelines at the moment aren't sufficient to really protect the future environment, definitely not. And it's a very slow process to change them. They are going to change because they're going to have to change. But it's a slow process to get the entire world to agree on a set of rules. So I think this is going to be an interesting area where industry is going to set the standard moving forward, because it's in industry's best interest to protect the environment. So that's going to go forward. But there's nothing stopping anybody from putting up a giant constellation, from every country putting up one and not caring about the orbit and things like that. So it's just something that like, it's a different sector to everywhere else. We can't wait for the guidelines to tell us what to do. We kind of have to say, we have to take that step to be responsible ourselves.
Yes, sure. Thank you, Zaria. And maybe we can jump into Tanvir, if you have any, from your perspective, and also about India and in Asia, if there are other things that there are not in Europe or things that is developing. You can go on.
Yeah, I think I would like to draw an analogy to aviation sector. So they manage collision risk predominantly by, there is an international body that governs all the aviation regulatory framework. So what they basically say is there is something, they have defined something called as separation distance. That is somewhere around 5 nautical mile over land space that is within the radar. And it's around 15 nautical miles when it's over oceanic airspace where you don't have radar coverage. I think we have to learn from the aviation industry and form an international body that governs such framework. And we start by defining what is situational awareness, what do you actually mean by a collision event, and if a collision event is happening, how should the stakeholders react? All this is really defined in the aviation industry, and no matter where you are from, no one violates these regulations. So I think a similar approach is needed in space industry. I think the space activities are dominant, like somewhere around 8 to 15 countries.
Sorry, Tanvir, can you get closer to the mic just 1 second because it's starting to not work again. Sorry for that.
Yeah, so I think the majority of space activity happens from around 8 to 15 countries. So if we are able to get the governments of these countries to form an international body, I think that would be a good start, very good start actually.
Okay, so as you said, usually space has been a monopoly of specific countries. Sometimes organizations like maybe a European Space Agency that represents more than one country. I'm also aware that in South America they're planning to create other types of collaboration, but we all know the story about space. So there used to be this huge monopoly on this kind of technologies, mainly because of the high, very, very high cost. But now it's become more and more, well, easier and easier to actually launch your own satellite, as we have been talking about the CubeSats, and this entails a lot of dangers or risks because it involves a direct exponential growth of the number of satellites in Earth. So I was wondering, so there's obviously there's way more companies trying to get into space because it's more accessible, which might be good. I will probably ask you first if you think it's good or bad, but also I want to know if actually, how do you think that we can actually promote these companies to try to access space, but in a sustainable way? So all of you can take the question, maybe Zaria or Bruno, since Tanvir just finished. So there's two big points of this. First of all, do you think it's good to have this huge accessibility to space? And then how, counting on this accessibility, how do you think it's possible to do it in a sustainable way?
Yeah. New space, here we go. On you.
Okay, I'll take the question. So, yeah, good. It's good for my business, so I'm happy with that. If I can take them into orbit. As I said when I started the conversation, before going. I think for your own sake, and I think all those constellations that Zaria were mentioning, it you can just launch it from any world virtually. I think they will have to, and everybody will have to look into the issue, because otherwise, if there's an issue with a satellite on their own, they will lose their revenue stream. I'll give you an example. So we did a simulation with a known constellation. Not necessarily with known, we can guess, but we did a simulation with a known constellation that said we can cope with about 10% loss of our satellites. So if we have the number of satellites in orbit, say 100, and they claim that their service is resilient and reliant if they lose 10% of those 100 satellites. Okay? So that means that at least we lose 10 satellites, and those 10 satellites are out of control. So these satellites were in a polar orbit. In a polar orbit, basically everything crosses the poles more or less at the same time, because we did a simulation, and basically by losing only 3 in 100, so 3%, these start to deviate from their slots, their orbital slots, because you lose control. So you can.
Okay. No. I think your connection is a bit.
Bruno. Yeah.
Bruno, you
can you hear us? We're having some problem to hear you. Can you try again, please? Is your connection okay?
No.
I think you might be muted now. Can you check? Because we can absolutely not hear you at the moment.
I'm not muted, and they can hear you well.
Okay, now we can hear you better.
Yeah.
Sorry for interrupting. Can you please continue?
It's fine. So the simulation was with 3% of the satellites, 3 in 100. Okay, we did a simulation only with 100. Deviated so much from their orbits that they bumped into about 20 of their own satellites. Basically, they lose 3% of the control of 3% of the satellites, which they say they can cope with, but they'll end up losing of their satellites. Close together, the same planes, same altitudes, everything, which means that actually it hits on their revenue stream. So if they don't plan, they'll struggle to hitting the pockets of these companies, then they'll think about it.
So sorry again. There's some technical issues with your connection, so we're going to ask you kindly if you can please close the session and join back again. In the meantime, we'll go to Zaria. can you please take over the question, because we have heard the industry point of view, but I also want to see the research point of view. Do you think it's good to have this accessibility? Obviously, for business, it's good because of economic reasons, I'm assuming. But can you please elaborate on the university or academia world point of view, please?
Yeah, well, I think it's great news, yeah. Even though I'm in space debris mitigation, I think the accessibility is just amazing. Like, originally I'm from South Africa, and I would have never thought that we'd have a thriving space industry, but now we're doing AOCS systems and just amazing work. So I think it's to start off with, it's great, because I love space, it's exciting, it's new. I think everybody should join it. We should all just leave our jobs and join the space sector. So it's great. But I think our mindset needs to change, because we're still thinking very much on a project-to-project basis. We're still thinking very much about reacting to certain things. So I feel like we're now kind of catching up to, oh, space debris is an issue. So the reaction to that is I should include a device that will help me deorbit to meet the mitigation guidelines. But like what Bruno was saying, we need to do more. We actually need to do more than what the current guidelines are saying. So I think it's amazing and great, but I do get kept up at night sometimes thinking about what the future is going to look like if it continues growing at this rate and we continue to kind of try and deal with the issue in the very near term. Because I think that's one big thing. It's like we talk about active debris removal, we talk about space debris mitigation, and in a lot of the conferences they're almost pinned against each other to say, you know, which is the best option. But we're going to need everything. We're going to need everything in our arsenal to kind of affect this. And until active debris removal is at a stage where it can work, we need to make sure that like space debris mitigation is being applied beyond what needs to be applied at the start.
Yeah, thank you, Zaria, for this answer. I hear that Bruno is back with us, so maybe you can just recap. We are about at 5 minutes at the end of the panel, so we can go back to you, the question we asked you about the application and of deorbits in the life cycle and the access to the space in this new space race. Yeah, you can go on.
Yeah, thanks. Can you hear me now? I hope so.
Perfect.
So the whole life cycle is the key, I think. I mean, planning particularly for the end of mission is very important, and there are several aspects that would prevent us from actually reaching that point. I mean, we can lose control of the satellite. You can lose communication. You can have your own satellite bump into something else, and you lose control. I mean, before the satellite gets to end of life, there's so many things that can go wrong. I mean, by all means, you can explode the launch pad. I mean, there's many things that can really go wrong. But we basically focus the mind of engineers, and they kind of forget that at the end of the satellite's life, they need to do something about it. And actually, we're very active on a few things. I mean, we actually demonstrating a drag sail as well in our upcoming launch with a partner. So they developed a German company that are developing a drag sail. So we're going to test that. We have our own deorbital devices. We're working with ESA on several projects about that. But at the end of the day, it's a commercial venture, because we passed that point where we're just doing engineering for engineering, science for science. We passed the point where we're now using space for commercial purposes, and this is when things start to go interesting, right? So prices drop. It means that we can put more stuff up there and generate revenue streams from whatever you put up there. But you know, like the ocean, you can't overfish it. Like the same thing in space, you can't overdo it unless you protect it. And we need to protect it for future generations. I mean, it's going to be your generation. I'm getting too old to think about it, but I hope to see it through. But it's your generation needs to come up with different ideas, and all ideas are welcome. All ideas are welcome, and we're happy to provide the support necessary to test those ideas if they're cool.
Those are very interesting points. In fact, I believe Zaria is actually working on her own deployment for a drag sail. So maybe at the end of this panel, you can have the opportunity to talk among yourselves.
Absolutely.
We will see. Let's just
She'll reach out and by all means, yeah.
Yeah, I can assure you she's a great person. So I don't know. I don't know what I'm doing. Let's just keep going. So actually, the last point. We only have 2 minutes. So I'm just going to ask a last question to Tanvir because of the technical issues. He had less time to talk. So Bruno just talked about testing. So how are you all actually going to test all of these constellations? How can you test all of these space debris methods? Well, removal methods. Sorry.
Surveillance, yeah.
Yeah, so when it comes to our own solution of space surveillance, we are launching our first satellite in next 14 months. So we'll be testing through our technology demonstration mission, and we'll be detecting both larger debris and medium debris. Speaking about deorbiting mechanism, I think there is quite a few actors that have to act there to make it a reliable space traffic management solution. First one would be the private space sector should have a positive attitude towards space traffic management. Second, a mandate from government that enforces space traffic management on the private sector and government sector alike, that establishes definition of conjunction events and everything in space traffic management. Third, involvement of insurance agencies and active removal companies, where the cost of active debris removal in a case of collision event, if it happens, is taken care by the insurance companies, and all the spacecraft operators basically bear the cost at the start of their mission. So, in my personal opinion, I feel this is a very practical way to approach it.
Thank you so much.
Thank you so much, Tanvir, for this answer. And yes, it's time for us to close up this discussion panel. So it was very interesting to discuss with all of you, with Tanvir Ahmed from Digantara. So it's a new startup making good thing in India. Bruno Carvalho from Portugal, the Orbits, which is also a
great initiative.
Great initiative.
And Zaria, which we're going to have soon again. So please, Zaria, bear with us. Now let's go into the break. We're going to come back with a 3, 2, 1 and lift-off workshop. See you soon.
See you.
I think you're still
We are still on live, yeah. Okay, they
can see us?
They can still see you, but then
Right, thank you all.
Bye.
Have a good day and great initiative.
Yeah.
Thank you so much.
By all means, reach out whenever. I mean, the Orbit also has a strong presence in the UK. We've grown the team there, so reach out. And I think Porsche will be happy to support our crimes initiative. He's very active on the UK sets environment, so reach out.
Thank you very much.
And we love Porsche.
You know Porsche, there you go. So reach out to her.
Will do.
All right, thank you guys. Enjoy the rest of the day. Bye-bye.
Thanks.
Thank you.
Okay, yeah. Yeah.
I don't know who can hear me.